Hi everyone, let me hope you are all doing fine. I'm back once again to teach you something new today. We have been talking about the curriculars, the integral curriculars. Today we're going to talk about something different, and that is applied mathematics. We're going to talk about probability. So many of you have been calling me, Master, when are you helping us with the paper 2? Now this is the paper 2, okay, where we find the applied mathematics. So let's talk about the probability. What is probability? So the probability of an event is a measure of the likelihood that it will happen and is given on a numerical scale from 0 to 1. Okay. In this area, we are going to talk about situations that are not certain. For example, if we gonna play a soccer match, you know, you are not very sure of the outcome. Are we winning? Okay. Is it gonna be a draw, or the other side is going to win? Okay. So such situations where we are not very sure of the outcome is what we call a probable situation. Okay. You are not quite sure about what is gonna be the outcome, but you can try to predict. Okay. Basing on the way I see my team, I think there is a 75% that we are winning the next game. Okay. Basing on how Arsenal has been performing, there is a 30% chance that they'll win the next game. Okay, those are probable situations, not very sure about the outcome, but we can try to represent it with a numerical value between 0 and 1. The numbers representing probabilities, okay, can be written as percentages, fractions, or decimals. So we can say the probability is 75%, or you may write this as 3 over 4, okay, which is the same thing as 0.75, okay, assuming for a certain situation you are predicting that there is a 75% likelihood. So you can write as 75, or you can write 3 out of 4, or you can write 0.75. So we can represent probabilities with the percentages, fractions, or decimals. But we know something about these percentages are not gonna exceed 100%. No, the maximum is 100, okay, because it is from 0 to 1. I remember when I was a student, there's a guy who came claiming he knew a lot of applied mathematics, and he started giving us some kind of tuition, some kind of coaching on paper 2. This guy gets a number from probability area, calculates it, and gets the answer as 30. So he told us, no, this happened is the probability is 30. Maybe there was a mistake, or he started talking a lot. The following day, only fools turned up for his classes. So we are very sure the probability will never exceed 1. And the smallest or the least is 0. Okay, 1 and 0 have particular meanings in probability. Let's discover. But before that, let me write for you some probable situations in life. Let's talk about experimental probability. Okay, in mathematics, an experiment is an activity performed which results into a probable situation. Okay, you'll get an outcome after performing an activity, but you are really not very sure which outcome you are getting, so it is a probable situation. For example, when you throw a die, a normal die is numbered from 1 to 6. It has 6 faces. So any of the faces can show up, either it is a face with the number 1 or number 2, number 3, or number 4, like that. But only one of them will show up. Okay. So your interest could be, obtaining a prime number. Okay. So the prime numbers will be 2, 3, 5. But you are not very sure they're gonna get a prime number. So that is what we call an experiment. You perform an activity that results into probable outcomes. That's what we call an experiment. So how do we define probability experimentally? Probability equals number of successful outcomes over number of possible outcomes. Okay, this is defined for equally likely outcomes that stand equal chances of showing up. Okay, for example, when we toss a coin has two faces. One we call it a head and then we call it a tail. So all the two faces have equal chances of showing up. So we see that those are equally likely outcomes. So probability will be number of successful outcomes over number of possible outcomes. You have seen so many situations when a coin is tossed. It happens when a soccer match is just about to begin, when the captain selects his side and then the referee tosses a coin. So this is a probable situation where we look at a coin as being fair. It gives equal chances of head or tail showing up. So if our interest is obtaining a head, okay, then the probability of a head will be a half, because we have two outcomes, either head or tail. So the probability of getting a head is 1, okay, that's the number of successful outcomes, over the total number, which is 2. So it is 1 out of 2. Let's talk about probability notations and probability laws. We're going to begin with some terms used and the definitions. These are specific terms that we must get ourselves used to, okay? We make them part of our lives as we study probability. So these are some of the terms that we must get ourselves acquainted with as we go on with probability, okay? The first one that is going to pop up so many times is an experiment or trial. So any statistical experiment or trial has a number of possible outcomes, okay? The outcomes, okay, will be the number of possible outcomes, okay, or the number of outcomes will be known. For example, when you throw a die, okay, then the outcomes are the faces. That's the first number, the 1, or first number, the 2, or first number, the 3, up to, okay, first number, the 6. Those are outcomes. And now these are 6 possibilities. That's why we are saying that it has a number of possible outcomes. Then next, the set of all of possible outcomes is called the possibility space. Sometimes we call this sample space. Sample space. Okay. If we list all the possible outcomes, then what we get is what we call the sample space. Okay. Then an event A, normally events are gonna be represented with capital letters. Okay. An event, okay, is a subset of the possibility space. Okay. So what are we saying? For example, if I throw a die, S will be a set of 1, 2, 3, 4, 5, 6, assuming this is an ordinary die. Okay. Now, A is an event. Okay. You may look at it as maybe the number obtained is a factor of 4. So here, if we are aiming at factors of 4, then we form a set out of the sample space, which is 1 and 2, then 4. Okay, those are the factors of 4. Okay, so this is very important for all of us to understand, and these terms will be used quite frequently. So we should really know what we are talking about, and we have to make this part of our lives as we move on with probability. The point we are emphasizing is the sample space and an event. An event is a subset of the sample space. Okay, we can form so many events from this sample space. Now we are looking at when a die is thrown and the number of possible outcomes. So the sample space is having the numbers 1 to 6. But one of the events that we are talking about is the score is a prime number. Okay, so S, S, we are looking at A as 2, 3, and 5. They are all coming from the S. We can look at some other event, maybe define B to be, okay, the event. Then we say the score is a number more than 6. Okay, so if you're looking at the score is a number more than 6, then when we check here in our sample space S, we shall have event B having the elements. I think there is no single element that is more than 6. So it is an empty set. Okay, so we can also look at maybe another event C. Okay, C, we are trying to look at maybe the number obtained divide 6. Okay, how many numbers here divide 6? We have 1 divide 6, 2 divide 6, and 6. So the same thing as writing factors of 6. So yeah, we can have so many events coming out of this sample space. So the point I'm emphasizing is event and the sample space. Events are represented by capital letters. Sample space is also a capital letter. In most cases, we shall be using S to represent the sample space, and then these other capital letters will be the events coming from S. What about when 2 dice are thrown? Okay, let's look at that. When 2 dice are thrown, there are 36 possible outcomes. Let's look at these outcomes. Okay, the 36 possible outcomes when you throw a die. Let's say that this is the first die. It will have faces 1, 2, 3, 4, 5. These are some of the possibilities. Then here we have, let's say 1, 2, 3, 4, 5, 6, and this is the second die. Okay, so the first can show a 1 and the second shows a 1. The first can show a 2. You could have a 2 turning up, then the second shows a 1. Oh, this is a 3 and a 1, 4, 1, 5, 1, 6, 1. Okay, these are some of the possibilities we can obtain. Remember, only one of these will show up. Only one, okay, will show up. Not everything will show up. No, it is only one possibility that you're gonna get out of this experiment. When you throw 2 die, okay, you'll get one of these possibilities. Let me do some small correction here. Something disturbing me before I continue to deliver this lecture. So this is a 6. Okay, so you can also have this situation. The first shows a 1, the second shows a 2. The first shows a 2 and the second shows a 2. The first shows a 3, the second shows a 2. Okay, 4, 2, 5, 2, 6, 2. Remember, we are performing an experiment of throwing the 2 dice, and then we look at the possible outcomes. Because here you get 2, you get 2 faces mixed up, but it's not a guarantee that what comes on the first will be what comes on the second. No, we are trying to fill up the possibility space so we can have some events coming out of this. Okay, let me go ahead and fill this. Looking at the possibility space here, we have 36 possibilities. Okay, if you have your time and you count these possibilities, then you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. up to 36. There are 36 possibilities. Okay. Now we can define so many events out of this. Okay. For example, we can say define A to be the event the sum of the two scores is 6. Okay, we are looking at A as the event. You know, any event is a subset of the sample space. So from this sample space here, okay, we want to look at that event where the sum, okay, is 6. The sum of the two scores is 6. So you can check and see that along this line, you will have a sum of 6. Okay, so that's what we call an event of an experiment. The sum is a 6. So it happens along that line. 1 plus 5 will be 6. 2 plus 4 is 6. 3 plus 3 is 6. 4 plus 2 is 6. And how many possibilities it gives us a sum of 6? That's what we are. Now we are advancing, okay? We are looking at what we call an event and what we call a sample space. So let me list the elements of A on the next page. But we could also define some other event B, okay? We can start B. We are looking at the two faces are the same, okay? Or the scores are the same. And you discover that B will be along this line. If you were looking at that event which gives the same scores, then that is B. It is along that line. So from this sample space of 36, we can get so many outcomes, okay? So in general terms, we shall use Venn diagrams to represent the sample space and an event. Since an event is a subset of the sample space, it lives inside the sample space. That's why you are seeing that this is the event here, and this is the sample space. Sample space, okay? An event lives inside the sample space, okay? So let's see, we are still introducing probability. We have not yet done anything so serious, but let's see some of the things that we shall be using here. We need to talk about the number of outcomes in the possibility space, then the number of outcomes in the event. How do we denote the number of outcomes in the possibility space and number of outcomes in the sample space? So most of us have seen this before. The number of outcomes in the possibility space is going to be denoted by n of s. And the number of outcomes in the event A is going to be denoted by NA. We shall not be only using A for the event. We shall be using other letters, but here we are emphasizing the number of outcomes in the event A because we have called it A generally for just purposes of education. But we shall be using differently capital letters for different events, not always A. So we have the number of the sample space and the number of outcomes in the event A. Then how do we write the probability of A? Okay, let's do this. Writing P of A for the probability of A. Then P of A, since we said, is number of outcomes, okay, over number of possible outcomes. Then probability of A is number of events over number of sample space, okay? Now, since A is a subset of S, okay? Since A is a subset of S, these are capital letters, try to be so sensitive about that. You have dealt with this before. This means subset, okay? A is a subset of S. So, 0 is less number of A less number of sample space. The number okay, of outcomes of an event is either 0, okay, it is between 0 and that of the sample space. You know, when you are listing a subset of a set, even an empty set which has no element is a subset. So the number of outcomes in A, okay, could be 0, least, or maximum, it could be called the number of the sample space. Okay, so 0 is less n of A, less n of S. Now we want to divide through by n of S. Dividing through by n of S, okay, gives, you have 0 over n of S less n of A over n of S less n of S over n of S. Okay, so 0 divided by anything is 0. That one, you know, it is a fact. So we end up with the 0 is less probability of A less 1. Okay, so it is still emphasizing a fact we have talked about at the start of this discussion. We said the probability of an event is a numerical value between 0 and 1, and this is proving it, that the probability of an event, okay, is more than 0 and is less than 1. But there are some situations when it is 0 and it is 1. Let's talk about those situations before we move on. Since this is the last part of the introduction, let's talk about that. So there is something worth noting here, okay? Probability of A equal to 0 means that event A is impossible, okay? For example, look at this. What is the probability that you'll watch the World Cup final that will be played in the year 2224? Okay? The year 2224. What is the chance that someone learning this lesson will watch that World Cup final? Okay, that is impossible because 224 years from now, I think most of us will be busy undergoing half-life. So I don't think whether any of us will make it. Maybe the grandchildren will make it, but you know that the probability is 0. Okay, so there is P of A equal to 1. This means that the event A is certain to happen. Okay, yeah. What's the probability that, okay, you will have, you know, your, maybe, I don't know whether this is, no, this is not good. Let me think of some other situation. Okay, what is the probability that you go to heaven alive? Okay, that is 0. Okay, what about you? What's the probability that you will die? That is 1. You are very sure you are going to die. Maybe some of you, but I don't believe. I think, anyway, let's watch. You never know. If you are saying, you never know what might happen, but I'm very sure all of us will die at one point in time. So the probability is 1. All right, ladies and gentlemen, I've just introduced probability to you. Let's meet in our next discussion as we talk about the complementary events and we see what is coming ahead. This is really going to be very, very interesting. Let me hope you enjoyed this. Feel free to inbox me a comment about this. If you like the lesson, you know, sure you like it, make sure you subscribe and click on the notification bell. Okay, that way if I share a new video, you'll be notified instantly. Thank you so much. Have a nice time.